Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter carbon atoms and its compounds. So last time what we have seen about hydrocarbons, right, which contains carbon and hydrogen. We have also seen what are saturated and unsaturated hydrocarbons. Today we are going to see structural isomers. Now what we understand by the structure isomers, right? Now if I take for example, my ethane, right? So if I have ethane, that is my C2H6. Okay. So how many carbons are there? Here you see two carbons are there in this case. Okay. And how many hydrogens here? I have written hydrogens like this. Everywhere I have written hydrogen in this way. Okay. So now if I take, then if I go for propane, right? Okay, and then if I go for butane after that, right? Then what will happen is, see here. Then you will see that let's make the carbon skeleton of the four carbon atoms for butane. Okay, so butane I know how many carbons are there. Four carbons are there, right? Okay, and then I know the tetravalency of carbon is, I need to write down here like this. Okay, so for propane, right? So I know that the general formula CnH2n plus 2. Okay, how many carbons are there? There are four carbons. So I'll write here 4, then 2 into how many? 4 are there plus 2. Right, so what it will come? C4, 8 plus, yes, so 10 carbons I need to have. Right, so if I write this 10 carbons here, see here, tetravalency like this of carbon, right, here you see. Okay, so is this the only possible skeleton? No, no. Is this the only structure which is possible? I just would like to know, right? So now I can draw more than one structure in this case. See here, what I can draw. If I put one carbon in the center and put another carbons like this, right? Only thing I need to remember is that what is the number of hydrogen should be same. That is 10 hydrogen should be there, right? Okay, see here, 1 2 3, 1 2 3, then 4 5 6 7 8 9 and 10. So this structure is also possible. So means what? Two structures are possible in this case, right? Two structures are possible in this case, which was not possible in what? Ethane as well as in propane also. Propane also this case is not possible. C3H8 if you try, right? Only one structure will be possible in that case. Okay. So only from butane you will see that two structures are possible, right? So both these structures have the same formula, that is C4H10. See here, C4H10, both the structure. Such compounds with the identical molecular formula but different structural formula are called as structural isomers. Right? Structural isomers means what is happened? Two structures we can have for butane, right? But you'll see what is the clause? The molecular formula remains the same. That is my C4H10 remains the same. So this is my structural formula for butane. Right. So see here, pentane. Okay. So how many isomers I have got for pentane? Here you see, these are what? Three isomers are possible. Right. Okay. Three isomers here you see, you'll get three isomers for pentane. Right. Here you see the, in a straight line you have written like this. Right. So three are possible: N-pentane, isopentane and neopentane. Okay. The same way what we have done for butane, in the same way you need to do here. Right, the number of carbon and hydrogen remains the same, right? The molecular formula remains the same, but you get three structures in this case, right? Then I have got a ring carbon compounds. Okay, so in addition to the straight and the branched carbon, what I have got some compounds which are in a ring shape. Okay, I have carbon arranged in the form of a ring. Okay, for example, I have got cyclohexane. Right, cyclohexane is nothing but my C6H12. Okay, what I have done, see here, I have written six carbons and they are attached to each other by a single covalent bond. Right. Now you see tetravalency of a, suppose this is carbon 1. 1, 2, 3, 4. Right. 1, 2, 3, 4. So likewise you see that the tetravalency of each carbon has to be satisfied. And just you need to write down the hydrogens everywhere like this. Here you see. I've written the hydrogen. Right. If you want to write the electron dot structure, what we have done. Okay. Single covalent bond. So two dots. That rule we need to remember. Single covalent bond, two dots we need to write. So likewise we can write cyclohexane, right? Then you see benzene is there. Okay, another organic compound, a very famous organic compound. Okay, which has got a following structure. It is a cyclic structure where you see alternate double bond and a single bond will be there. Alternate double bond and a single bond will be there. Right. Okay, for every carbon you see tetravalency is meeting. See here, suppose this is carbon 1. 1, 2, 3, 4. Okay, this carbon 1, 2, 3, 4. Likewise. Okay, so alternate double bond and a single bond is there. Okay, if I want to write down like this, what you see here, two lines means four dots will be there. That we need to remember. Single line, two dots. Okay, so this is my structure for benzene. Student, I am sure you have understood today's topic, that is structural isomers, right? So you are confident enough to draw the structures of butane and pentane as such. Also, we have seen what is a ring carbon compounds. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.